All right. So, kind of do a slightly different approach here today. We'll start with Module 12. About halfway through, I'm going to do some review so that we can connect with some of the new concepts we'll talk about in Module 12 and connect that to what we were talking about with monopolies and perfectly competitive markets. Okay? So before we get going, a couple housekeeping stuff. What's due at the end of the day on Friday? That fourth discussion, Canvas discussion. Now, Thanksgiving break, if you're taking off early for that, I don't want you to forget about that and then come back after Thanksgiving break and realize you missed that. So get that done early in the week. Do it today, do it tomorrow, do it prior to Friday, at the end of the day when it's due, so that you make sure you're getting on and getting that done before you leave, okay? So that's kind of the only other thing that we have. Assignment-wise, the quiz and module reading, because we have Thanksgiving break, instead of being due Monday next week, we don't have classes, it won't be due until the following Monday, right? So the next quiz and module reading, you technically will have an additional week to do them. They're not due until that Monday we return after Thanksgiving break. Now, my suggestion would be not to wait that long because then you're a week further removed from the material, especially for that quiz. So maybe make sure you're getting on. You can complete that quiz after class Thursday, anytime before we come back. At the end of the day, that Monday we return from classes. But, you know, that's individual specific. I might not wait until that Monday to do it because then we're over a week removed from the material, right? CL sessions will also kind of follow a similar thing. They're going to be available this Thursday, right? They'll cover Module 12 material. We then won't have them on Monday because that's Thanksgiving break, but there will be CL sessions that Monday we return from break, right? So we're still going to get Thursday and Monday CL sessions. There's just going to be a week in between where we don't have anything, okay? So, you know, everything is going to kind of pick back up after Thanksgiving break. That Monday we return, we'll have CL sessions. We'll also have that Module 12 quiz and the Module 13 reading due that Monday night after we return from break, okay? Also, I will likely post an announcement tomorrow. One of my CL leaders is dealing with a sickness. I'm guessing 3 of those 9 CL sessions this Thursday will be canceled, given kind of their current status. If they make a nice miraculous recovery, there might not be any cancellations, but keep an eye out. I believe it's the 520 in Woodburn and Ballantine 104 at the other 2 locations, but I'll put that in an announcement, and I'll mention that in Thursday's class as well if he ends up having to cancel those sessions, okay? Other than that, I think that should kind of do all the housekeeping stuff. One more thing I wanted to mention, you might see pop up. I tried to update the CL points that didn't include last night, so I will do that again tomorrow when I'm in the office. So by Thursday's class, the Canvas points, or the CL points you see on Canvas should be updated. They might not quite be correct if you attended CL sessions last night because that wasn't recorded yet. So by Thursday's class, those CL points, I should have them all updated to be kind of current and kind of what you've attended. And then also tomorrow, I'm going to post up the practice final exam. So I'm getting that out early so you can start working with those questions. We haven't covered all the material. We've still got new material this week, and then we have 1 new week of material once we return from break. But I'm getting that out early so you can start reviewing those kind of earlier module questions as we get closer and closer to that final exam date. So any questions logistically about the course before we jump into material here? Did you have a question? Or was I trying to ignore you? Did someone here have a question? Did I see a hand? I answered it? Okay. That's what I was hoping. Okay. Any logistical questions before we dive into material here today just about the course? Is that clear what I'm saying about Thanksgiving break? Basically just kind of extending those due dates to be 1 week kind of further. Okay. All right. So we've got Module 12. I'll kind of start with that. At some point, we'll kind of dive into this Monopoly example Excel file that I have under the Module 11 materials we didn't get to last week. We'll kind of look at that later on in the class as well. So if you want to have that pulled up for when we get there, that's what we'll be looking at today. But we'll start out kind of a very different way of thinking, but I'll try to connect the dots between these models and what we've already talked about along the way. So Module 12 is basically looking at what we call game theory, right? So it's a whole different topic, sector of economics, but it allows us, it's another tool we have to understand every other economic situation. So whether or not this is consumers trying to maximize utility, firms trying to maximize profits, we're just going to think about it in a slightly different way or context. So kind of, if you haven't, there's this, I guess it's pretty old now. I don't know when it came out, like 2001. It's called A Beautiful Mind. It's about the guy who came up with essentially, or really helped revolutionize game theory and economics, John Nash. I think he was schizophrenic. He saw people that weren't there, but like a genius dude, right? Came up with like all these crazy models. We're going to look at very simplified models of what we came up with and identify what we call Nash equilibrium. So we've talked about equilibrium throughout the semester. We're now going to talk about what we call Nash equilibrium, which is slightly different. Right? So a Nash equilibrium is going to be where we have people making decisions, right? And we are both best responding to what the other person does. So I always kind of usually set this up in the context like the schoolyard game of chicken. If I'm running at someone and they're running at me, and at the last second we both have to make a decision, hopefully we both go different directions, right? So we don't run into each other, right? My best response to what that person does is to go the opposite direction of them. That's the simplest what we're trying to identify. What are going to be these kind of Nash equilibrium or the best responses of both people, right, given the game that we're looking at? Now, we'll look at several different types of games. We'll put this in the context of markets, but then also in like consumer decision making, okay? So what are our kind of basics going to be? We're going to have players and rules. So our models today, we're only ever going to look at games where we have two individuals, two firms, two countries, two workers making decisions. So two people models, we can make this to have as many people as we want. The math just gets harder. We won't do that in this class. So two people, right, making decisions. When decisions are made are going to matter. So everything we do today are going to be what we call simultaneous decision games. We're making these two players are making decisions at the same time, simultaneous decisions. Next class, we'll look at some games which we call sequential, which is player one makes their choice first, and then seeing that choice, then player two gets to make their choice. So today we're just looking at simultaneous games. Next class we'll focus more on this when decisions are made and look at sequential games as well and see how those equilibrium might differ. Okay? Excuse me. We're also going to keep it simple today. I might show you a couple examples on Thursday. At most I would push you on the quiz or exam is 3 decision games, but we're mostly going to be simplifying this down to 2 decisions. Right? So these 2 players have strategies they can choose from, just 2 strategies. They could have 50, right? But we're going to keep it simple and just keep it at 2. If we can solve 2 decision games, we could solve 50 decision games. It would just take longer, be a little bit more math. And then what we're also going to want to focus on is how do we determine what choice somebody wants to make? Well, where are their payoffs higher? If this is for an individual, it's where utility is higher. If it's for a firm, it would be where profits are higher. So the payoffs to these different combinations of strategy choices are going to be how we identify what is the best response for the person or the firm making this decision. Okay? So our players, our strategies they can choose from, and then the resulting payoffs are going to be what we're looking at, usually depicted in, I'll skip ahead a little bit, a normal form game that looks something like this, or a normal form game matrix. Okay? So what we're going to do is we're going to have, I'll set this first example up, is our players are 2 firms. Their strategies, now we know in practice they could set a bunch of different prices. We're just going to say they could set a low or a high price. Keep it at 2 for right now. Simplify it. And then given the different combinations of those choices, what are the payoffs of the firms? So we're always going to put player 1 on that left-hand side. They can choose to either set a high or a low price. Player 2, we're always going to put on top, and their combination of, their strategy choices are high and low as well. Okay? Now, when we look at different games, maybe the strategy choices of the individuals will vary, but for now we're going to keep them kind of symmetrical. They can both either set a high or a low price. This box represents the combination of when player 1 is choosing a high price and when player 2 is choosing a high price. If they both set a high price, here is person 1's payoff, here is person 2's. So the way that you can think about this, and it gets a little bit tricky when you're looking at the book, or if you were to look at outside sources, a lot of times you'll see the normal form matrix depicted like this. The way that I describe it to kind of keep it easy, and when we start working through examples, I'll show you the ones that I give you, and I think it makes it a little bit easier. But if you were to see something like this, player 1 is on the left. Their payoffs are always in that bottom left corner. Player 2 is on top. Their payoffs are always going to be in the top right corner. Okay? So here is player 1 and player 2's payoffs if they both set a high price. Here is player one and player two's payoffs if they both instead choose to set a low price. So if we both have two choices that we can choose from, there will be 4 different combinations of those choices, right? Or 4 different boxes. Okay? We will then use the payoffs from all those combinations of strategy choices to figure out what is the best choice for each individual to make. That's kind of our setup. Okay? Any questions over anything I've said up to this point? Does this sound, hopefully the top hat reading was kind of similar to this. So, excuse me. A couple other definitions we'll have, and I'll give you some non-theoretical ways to remember this. But a dominant strategy is going to be when player one or player two, their choice does not depend on what the other person does, right? So this might be if I'm thinking about if I'm taking the exam, right? The amount of hours I choose to study, I don't care what the person next to me chooses, how many hours they choose, right? I'm always going to choose to study more. If they study more or less, I'm always going to choose to study more. My action does not depend on what they're doing. That's the idea of a dominant strategy. Now, like in a group project, how much time I put in, if the other person isn't studying at all, I might have to put in even more time. There, my choice depends on what my group mate is doing. There, I wouldn't have a dominant strategy, right? So a dominant strategy is when a player will choose to do the same action regardless of what the other person chooses to do, okay? If we have 2 dominant strategies, we definitely know a Nash equilibrium is going to exist. So for example, if I have 2 firms and the optimal strategy is I always set a high price and the other firm always sets a high price, we know that the end result will be we both set a high price, right? So if we have 2 dominant strategies, we have what we call a Nash equilibrium, or we know that we're going to have the outcome where, well, if I do the same thing regardless of what you do, we always know what the outcome will be, right? And then we'll talk about, and this will make sense when we have more examples, but a prisoner's dilemma, which is when we have a Nash equilibrium that exists where the payoffs to both players are lower than if they could agree to a different combination of strategies, okay? Excuse me. So I'll set this up. Why is it called a prisoner's dilemma? Yeah. It's not possible. So we'll work through it. If you have 2 dominant strategies, you're going to definitely have a Nash equilibrium. Yep. So we'll walk through some examples. I think that question will be a little bit easier to kind of figure out. So let's do the kind of setup first. And this is kind of a weird one, a little bit outside the context of markets, but where we come up with this term of prisoner's dilemma. Okay. So let's think about we have this setup where we have 2 suspected bank robbers. They don't know each other. They just agreed to go rob this bank together. They don't have enough evidence to put them both away for a long period of time. So they put them in separate rooms and say, look, if you confess to the crime, you get to go free. And if the other person doesn't confess, we're going to put all of it on them. So if you confess and the other person doesn't, you get 0 years of jail time. They get 25 years. If you both don't confess, we don't have enough evidence to put you away for a long time. You're both going to get 5 years in jail. And then if both of you confess, well, you've both ratted out your partner. We now have evidence on both of you. We can put you both away for 10 years. Nobody gets to go free. We now just have additional evidence on. This is the setup of where this prisoner's dilemma comes from, right? Cops try to do this. This is where they put suspected bank robbers in separate rooms. We're making simultaneous decisions. I don't know what the other person is doing, but I know they have 2 strategies: to confess and rat me out, or not to confess. Okay? So this is the setup. Now, I could build this out, this normal form game. I'll kind of talk through what this would look like and give you a depiction that might be more similar to what I would give you. And also, the slides are great, but I've been doing some teaching reviews, and people rely way too much on their slides, and I just see their students, when I'm doing those reviews, gloss over. So I'll probably be doing a lot of drawing today, even though some of this stuff is already in the slides, right? So let's think what this would look like, okay? So I've got, just to make sure I keep the players the same, Dan and Joe. So this is player 1, this is player 2, right? Dan can choose to confess or not to confess. And then Joe has that same decision when pulled into that separate room to either confess or not confess, okay? So we have 4 different combinations of these strategy choices. If they both choose to confess, this was the idea, well, I now have evidence to put both of them away for longer. They both end up with 10 years in jail. Okay? So instead of using these kind of diagonals, a lot of the examples I'll show you or give you on the quizzes and the exams, I'm going to use this form. I think it's a little bit easier, and I'm not trying to confuse you. I want you to be able to solve these games. I don't know where we came up with like this matrix form. Well, I kind of know where they came up with it, but we can use commas to separate, and there it makes it easier. I just write everything sequentially. Player one, their payoffs are going to be first, comma, player two's payoffs then come second. Same kind of idea when you had those diagonals. It was still player one was on the left, player two was on the right. I just think this depiction makes it a little bit easier. Right? And I want to focus on making sure we can solve these games. So he said if they both don't confess, they could only put them both away for 5 years. And then if Dan confesses, how many years did he get in jail? If the other person doesn't confess, but I do, the deal was that if I confess and they don't, I get to go. So their jail time would be 0. Remember, their player two, their jail time is now 0. The person who didn't confess, they now pin it on them. They get 25 years. Kind of reverse. If Joe confesses but Dan doesn't, Joe gets to go free. They pin it all on Dan. Now, I think every example that they had in the book, higher payoffs were always a good thing. This is a unique example and probably one of the only ones, and I wouldn't actually put something like this on the exam or the quiz. Generally, what we're talking about when we put this in the context of markets, because that's where we're eventually going, are firms and consumers. Consumers want to maximize utility, so higher values are always good. Firms want to maximize profits, higher values are always good. It gets a little bit weird when I have a jail time example, because what number is actually better? Going to jail for fewer years, right? So I could think of like jail time as like the loss of years of my life and make these all negative, in which case we're still choosing the higher payoff. But in the context of this example, what is the better payoff to the individual? Being in jail for less time. So we're actually going to be looking for the lower number here. Almost every other example I give you, we're going to be thinking about the higher value is preferred, right? It's just here we have a slightly weird example to kind of set this up, which is jail time, which is a negative thing, right? So this is how I would solve these if I were you, right? People ask me, how should I be solving or what solution should I be drawing? I'm telling you, this is what I would do, right? So I'm going to go through and I'm going to use colors. If you have tablets or things, it might be good. Player one is going to be red. I'm going to make player two blue, okay? So we're going to figure out what is player one's best response to all the possible choices of player two. Now we only have 2 choices here. If Dan confesses, what should Joe do? Well, if he confesses, he gets 10 years in jail. If he doesn't, he gets 25. Which of those is preferred? 10, right? If Dan doesn't confess, what is Joe's best response? Well, if he confesses, he gets to go free. If he doesn't confess, he gets 5 years in jail. Which of those is preferred? 0 years in jail. So this is not a technical way of remembering it. But if you ever have 2 circles in the same row, that means that there is a dominant strategy for player one. Here I've got 2 circles in the same row, or what that's telling me is no matter what Dan does, it's always Joe's best response here to confess. His strategy choice does not change when Dan changes his decision. It does not depend on Dan's decision, or Joe has a dominant strategy. Less technical way when we're solving these games, 2 circles in the same row, that's a dominant strategy for player one. Okay? Any questions on that idea? So I now know player one's best responses to both the possible choices of player two. The next thing I need to figure out is what is player two's best response to all the possible choices of player one. So once again, I'm using markers. You could use your hand to do this. It's just my hands get a little big and sometimes I'm hiding things, so I'm going to use these markers. What should Dan do? Remember, he's player two. His payoffs are on the right. if Joe confesses, what should Dan do? Well, if he confesses, he gets 10 years in jail. If he doesn't, he gets 25. Which of those is preferred? If Joe chooses not to confess, what should Dan do? Well, if he confesses, he gets 0 years in jail. If he doesn't, he gets 5. What's better? 0 years in jail. So anytime I have two circles in the same column, right, this is going to identify that I have a dominant strategy for player 2, right? So non-technical way of remembering this, right? That is another way of thinking about how you're identifying these dominant strategies. Mm-hmm. Yeah, right. So we can think through this thought experiment, right? So hold off on your question. Come back to it before we get here, right? So if I've identified the best responses, anytime I have two circles, once again, not a technical way of saying this, but two circles in the same box, right? What is that really representing? That both individuals are choosing their best response to the other person's strategy choice. Or my best response, I'm best responding to the other person's best response. So two circles in the same box, this is going to identify our Nash equilibrium, right? We know that both players have a dominant strategy, to the question earlier, to confess. So what do we always end up with as our Nash equilibrium? Both people always confess, right? Now, is this a good or a bad thing? Well, this is our equilibrium. We're both going to get 10 years in prison. The reason why we would call this game an example of a prisoner's dilemma, if we could somehow agree ahead of time before they take us into these separate rooms, if we instead both didn't confess, we would actually both be better off, right? So we can end up with equilibrium where both people are actually worse off. That's the definition of a prisoner's dilemma. So why do we know this won't exist? Let's assume they both aren't confessing. If I'm Joe, what should I do? If Dan's not confessing, what should I definitely change my choice to be? Not confessing. So there's always this incentive that pulls us away from, essentially, you can think about it like that point where they're both getting 5 years. It's almost like a socially optimal point. But there's incentives when we work out of self-interest that push the market or the individuals to a different equilibrium. What does that sound really similar to? If the market equilibrium doesn't line up with society's equilibrium quantity, we have deadweight loss, but those exist because we have externalities, right? So because people act out of self-interest, we end up with these Nash equilibrium that aren't in the best interest of society, or this is a weird one because it's a two-person society, but society, they would both be better off if they could agree to not confess. But there's always this self-interest that pulls them away from that point. Yep. So it's kind of a counterintuitive result when we have these prisoner's dilemmas. Yep. Any other questions on this idea before we keep moving? Mm-hmm. Almost always. What did I say about this example? Why is it weird? Because it's jail time, right? So you could actually, if you wanted to, thinking about you're always choosing the higher number, jail time is really just a negative value. It's just weirder to talk about directional change with negative values. So every example from here on out, we'll think about firms are going to want to choose the higher profit level. Consumers always want higher utility, right? So this is just a weird one to set us up. Yep. One-time decision. We're not going to look at repeated games here. Yep. Any other questions before we keep moving? So this is how we would kind of solve these games, right? So if I'm thinking about, we basically just went through this, and we found this Nash equilibrium that both players had a dominant strategy to confess. Two circles, same box. They're both best responding to each other's best response. That's our Nash equilibrium. It's an example of a prisoner's dilemma because if they could agree to a different combination of strategy choices, they could both be actually better off than the equilibrium we ended up in. Okay? So, right, that's kind of a summary of everything that we just said. Let's look at this instead in like a firm context. right? Because that's really what we want to eventually, we want to be applying it to, right? So let's say I've got this example where I have two firms, right? Those are my players, firm one, firm two. If I'm a monopolist, right, what do I want to do? Relative to a perfectly competitive market, we know the monopolist will choose a higher or lower quantity. Lower, and they will set a higher price. So let's say that there's two firms that can identify that, and they come together and they go, look, we're the only two firms selling phone plans in this area, Verizon, T-Mobile. Let's act like a monopolist. Let's set the quantity together, right? That would be the monopoly quantity. So they both choose a quantity of 30. Total quantity in the market would be 60, and that's the monopoly quantity. Now, they both have the option to increase quantity, right? So I can either agree to that monopoly quantity of 30 and produce that, or we'll keep it simple. I could choose a bunch of different quantities. We'll just say I could produce 30 or 40, right? Keep it nice and simple, two quantity choices. If one firm produces a higher quantity, what's going to happen to supply? It's going to increase, which will do what to the equilibrium price? Lower it. So I'm going to give you an intuitive explanation why the profit values I'm going to show you are what they are, and then we're going to solve the game. I won't expect you to kind of come up with these payoffs on your own, but I do want to give you the explanation as to why these payoffs would look like what they do, okay? So I've got this here, right? How did I come up with these payoffs? Okay, so I did Verizon and T-Mobile were my two players or my two firms here. They have two choices. They can produce a high or a low quantity. Thinking about that low quantity would correspond to like a quantity of a monopolist. The higher the quantity, we're getting closer to the perfectly competitive outcome, okay? So if we both restrict quantity, maybe we could both have profits of 900. So this would almost be like monopoly profits are 1,800. There's two firms splitting it evenly. They both get 900. Now, if we think about our profit equation, it's going to look like this. So if Verizon is red, if Verizon increases quantity, right, what's going to happen to that equilibrium price? Well, we said if they produce more, but T-Mobile sticks true to the agreement, quantity in the market is going to go up, so it's going to push the price down. So the price will go down a little bit, but remember, Verizon is now selling more units. So what potentially could happen is Verizon's profits actually go up. Now, for T-Mobile, if they hold true to the agreement, the price still went down because of what Verizon did. What happened to their quantity? Well, they kept it the same. What's going to happen to their profits? Definitely go down, right? So the firm that holds true to this agreement, they kind of get screwed here, right? Because they agreed to reduce quantity. They stuck true to it. But because the other person backed out, that pushed the price lower. Their profits are actually now lower than before because they held true to the agreement. Okay? So that's kind of where these numbers are coming from. So on the flip side, if Verizon holds true to this agreement, but T-Mobile doesn't, T-Mobile's profits go up, Verizon's go down. And then if we both produce a higher quantity, well, we're both selling more units, but now there was an even larger reduction in price. So maybe now we get profits look like that for both firms. Okay. So I wouldn't ask you, like, make you reconstruct these values, but like this is the reason why these payoffs look like they do. So all I'll expect of you is I'll give you the payoffs, and then what will the equilibrium of this game be? So if I'm solving this, if I'm not dropping my markers, all right, what I'm going to first go through and do is say, okay, look, if T-Mobile chooses to stick to that agreement and set a low quantity, what is it optimal for Verizon to do? Well, if they set a low quantity at 900 in profits, so think about these values represent firm profits. If they set a high quantity, profits are 1,000, what do they want? Higher profits, so they would set the quantity at 40. If T-Mobile breaks the agreement, what should Verizon do? Well, if they hold true to the agreement and only restrict quantity to 30, they get 750 profits. If they also break the agreement, they get 800. So 2 circles in the same row, player 1 or Verizon has a dominant strategy. Now, what about T-Mobile? Given Verizon's choices, if Verizon chooses to hold true to the agreement, what should T-Mobile do? Well, their payoffs are on the right. So what should they do? Profits are higher if they choose a quantity of 40. We've got to be able to compare values here, right? 1,000 is greater than 900. What if Verizon sets a high quantity? T-Mobile, what should they do here? Set a high quantity because profits are higher. 2 circles in the same column, player 2 has a dominant strategy. So here we have another example where we have a dominant strategy, Nash equilibrium, because both firms had a dominant strategy to break the agreement. It's always better, it's always in my self-interest if the other person holds true to the agreement to be the one that breaks it. Right? Now, our Nash equilibrium, or where we have 2 circles in the same box, right? Not the most technical way of saying it, but that's an easy way to remember it. We now have profits where both firms are 800, right? What is this an example of? Similar to our last one. Is there another combination of strategies where they could both be better off? Well, let's say they did this combination. Firm 1 is better off, but is firm 2 better off? No. What about here? Well, firm 2 is better off, but firm 1 isn't, so no. What about here? Firm 1 and firm 2 would be better off if they could agree to act like a monopolist, but there was always the incentive pulling both of them away from that agreement. So we have a Nash equilibrium where both of them are worse off than if they could come up with a different combination of strategy choices. So this is an example of a prisoner's dilemma, right? So this is a bad news for the firms, right? Because it pushes us further away from that monopoly point, right? Who is that a good thing for? If we're pushed, if it's getting them further from the monopoly point, closer to perfectly competitive, that's a good thing for consumers, right? So consumers, we love this prisoner's dilemma for firms, right? If I'm a firm, I don't love it. Correct. We haven't looked at an example. We've only looked at prisoner's dilemma examples. I've got an example we'll look at in here in a second where we have a Nash equilibrium, but not necessarily a prisoner's dilemma. What do you, so this is the we haven't factored in consumer surplus here, right? We're just looking at profits for the firm. These don't have to add up to the same values. Yeah. In fact, we know they won't, right? Monopoly profits are positive, whereas perfectly competitive profits are 0. In fact, we basically, notice what's happening. I don't just have 2 quantity choices, right? I could produce 30, 40, 50, 60. What would happen in my normal form game? It just gets bigger. What is the prisoner's dilemma always doing? Pushing me to higher quantities, lower prices. Eventually, I'll get down to where profits are equal to 0. So the prisoner's dilemma with these firms makes it good for us because we know that it's going to push them towards that perfectly competitive outcome. Profits are equal to 0. But what's also true at the perfectly competitive point, consumer surplus is higher, right? So consumers like this, right? And also, what's happening as we get closer to the perfectly competitive point? Deadweight loss is getting closer to 0 as well. Okay. Any questions just about kind of solving these models here? Any questions over anything I did here? Okay. All right. So I basically have this in the slides. I just kind of worked through it here. Now, what we're going to get some practice doing, because there were some good questions brought up along the way, is, and I think I have this set to be, I'm going to actually change this before I give you the number, because we won't need this much time on it. So let's see. I'll have it set to be due right at noon here. So we got 15 minutes that we'll look at this. It should now be published on the main homepage or under the quizzes tab. And the number to get you in should be 20.24. So 20.24. will get us into that quiz. We'll then kind of think about some additional games that we should be able to solve. Okay? Any question? Wi-Fi working okay? Working pretty good this morning, a little bit slow. So hopefully kind of as we talk through these, right, everyone's be able to kind of get in, get these opened up. 20.24 is the number. I'll kind of do some check-ins about Wi-Fi in the next couple minutes, right? So let's first just think about this game. Once again, how did I give you this game? It wasn't depicted using kind of those diagonals. I'm using this kind of separation with a comma. Player one is always on the left, United Airlines. Their payoffs are going to come first. Player two is American Airlines. Their payoffs are always going to come second here. Okay? Now, this should look similar, and this won't always be the case, so don't get confused. But we have symmetric payoffs here, and we've had that in a lot of the examples we've looked at so far. So here, I'm setting this up using slightly different language, but basically, I've got two companies or two players, and they're making a choice between cutting fares or not. So airline fares are essentially the price. So I can think about cutting fares is really just setting a low price, and not cutting fares is keeping prices higher. So maybe I think about people traveling around Thanksgiving. These airline companies have a decision to make, right? So we were given the payoffs, so we're just going to write those in here real quick. So 800, 200, 200, 800, and then here we add 600. Okay? I'm going to make United red, and I'm going to make American blue. I think this might flip-flop with what's on the quiz, but here we'll do all the work here, right? So it shouldn't matter. So if I'm United, right, and I'm thinking about it's holiday travel season, what is my best response to all of American Airlines' possible strategy choices? So if American chooses to cut fares, what should United do? Well, their payoffs are on the left. If these represent profits, right, what should United Airlines do? Cutting fares results in 400 versus 200 or higher profits. What if American doesn't cut their fares? What is it optimal for United to do? Well, if they cut fares, they get 800. If they don't, they get 600. Two circles in the same row, player one or United Airline has a dominant strategy. Now, if we do the same kind of thing, right, but we think about for American, if United cuts fares or sets a low price, what should American Airlines do? Their payoffs are on the right, so they should choose to also cut fares. If United doesn't cut fares, what should American Airlines do? Cutting fares, 800 is better than 600. Two circles in the same column, we would say American has a dominant strategy. So we have two firms with dominant strategies. We're definitely going to have a Nash equilibrium where both people are best responding to each other's best response. Or, non-technical way, two circles in the same box, right? So our Nash equilibrium is that both airlines will cut fares around the holiday season. That's not good for them, but that's good for us, right? That means there's high competition in this market. So this Nash equilibrium is an example of a what? Well, if we look at different strategy choices, are both people better off here? No. Would they both be better off here? No. But are they both better off with this combination of strategy choices? Yes. So our Nash equilibrium leads to lower payoffs. This would be an example of a prisoner's dilemma, right? If we could somehow agree with each other to keep prices high, both of us would be better off. The problem is, if I agree to that, as soon as I cut my fares, what does everybody do? Buy from me. So there's always this incentive that pulls these firms away from this agreement, right? Any questions on kind of how you would solve this model or anything that I did here? So what should our Nash equilibrium in this example be? Both firms cut fares, okay? Any questions on that idea? All right. Now, question 2 is a little bit different. Okay. So question 2, this is one where we're not going to have a prisoner's dilemma. I'll spoil it for you here first, right? So we have these payoffs, and I think I called them persons, but we can kind of think about this as like worker 2 or worker 1, and they can work hard, or this kind of weird term that we see in labor economics, which is shirking. I think this is like an English word, I say English, like from England, right? Like this is like they're shirking, you're slacking off, right? You're not working hard, essentially. So I have 2 choices as a worker. Maybe we could think about this in the context of a group project. Maybe some of you, this makes it a little bit more relevant to your lives, right? So I'm given these payoffs, and what I can think of these payoffs as being, for now, we'll just think about this as the worker's utility. This could be wages or income. Now, these values would have to be scaled, obviously, but right? Ultimately, what we're trying to figure out is what is the best choice for these workers to do if they're trying to maximize utility. Often higher income will result in higher utility. So we could have examples where we're thinking about this might result in, if I work hard, maybe my department is paid more, right? So these could represent like wages or income. Or if you think about like in a group project, if I have 2 different workers or students, the payoffs might be utility I get from the grade I receive, right? So all we care about is that these somehow represent utilities of these individuals. So we always want higher utility values. So we're looking for the value that's higher in terms of the payoff. So I'm going to make person or worker 1 red. I'm going to make person or worker 2 blue. So if I go through and solve this model, right? If person 2 chooses to work hard, what results in a higher payoff for worker 1? 10 is greater than 6, so also to work hard. Maybe person 1 really wants to get a high grade, right? So as a result, if person 2 shirks or slacks off or doesn't put a lot of time into my group project, what does person 1 do? Well, where is their payoff higher? 7 is greater than 4. They really want a high grade. So regardless of what person 2 does, person 1 is always choosing to work hard. So if this is like in a worker context, I really want to make sure the job is done right. I don't care what my coworkers do. I'm going to put in a lot of work. In a group project, I don't care what my group mates do. I want to put in a lot of work to make sure we get a good grade. I have a dominant strategy. Now, what if we think about for worker 2? These SOBs, right? They don't really care about their grade as much. So if worker 1 is choosing to work hard, what should worker 2 do? Well, if they work hard, they get 8. If they slack off, they get 9. They're going to slack off. If worker 1 chooses instead to slack off or shirk, what should worker 2 do? Well, I want to keep my job, or I might not care about my grade, but I want to make sure we pass, right? So if person 1, the person who's maybe smarter, really cares about their grade, doesn't put any effort in, 5 is greater than 4, right? So here, notice, I don't have 2 circles in the same column. So the choice of worker 2 depends on what worker 1 does. If their choice depends on what the other person does, they don't have a dominant strategy, right? Their choice will depend on what player 1 chooses to do. So we can have examples where one player had a dominant strategy, but the other player does not. Now, even though we don't have 2 dominant strategies, what do I still have in this game? 2 circles in the same box, or I still have a Nash equilibrium, right? So there's still going to be an outcome. I know the outcome of what this game will be, right? It's just now it's not a dominant strategy equilibrium because one player doesn't have a dominant strategy. Now, notice what ends up being the case, the person who valued the grade more or valued getting the job done right more, they always end up working hard. What is the equilibrium? Person 2 slacks off. They ride the coattails of the other person for the group project. So, bad news if you've got a group project right now and you really care about your grade, right? That the people that don't are going to basically rely on you to put in that hard work. Okay? And we would just be modeling this with different utility values, and we could apply it to a group project, like I said, or a department specific. If we're looking at a specific industry, company, and the department, this is basically just like how much each department, kind of their output, maybe they were putting out to like meet different criteria of the firm, right? So we can still identify Nash equilibrium, but they're not necessarily dominant strategy equilibrium. And then I forget who asked the question earlier. This is a Nash equilibrium, but isn't it an example of a prisoner's dilemma? Well, if we were here, would both people be better off? No. What about here? No, they're both worse off. What about here? Well, person one is better off, but is person two? No. So we don't have a prisoner's dilemma. A prisoner's dilemma is a Nash equilibrium where there's another combination of strategies where both people are better off. So here we have a Nash equilibrium, but it's not a prisoner's dilemma, right? So those do exist. We just haven't really looked at any examples yet. And we're going to work through a lot more examples on Thursday's class to kind of see, so we see more than just the prisoner's dilemma, which would look something like this. So here, we're not comparing, we could make other statements. I think you're thinking about like total surplus essentially, like for the combination. If these individuals are only acting out of self-interest, it doesn't matter, right? We're just thinking about they're making the choice where their payoff is higher. Now, if we want to start to think about where is like the socially optimal point, there we want to have it where total utility for society is, that's a whole, I mean, there I'm combining different, I won't do that to you guys. But you could use these models and think about, and basically what is that saying? It's not quite a prisoner's dilemma, but it gets closer to something along those ideas, right? Where there's actually a point that's better for society, right, than what the Nash equilibrium is. But I won't push you guys that far. But you're thinking about, you're connecting the dots the right way. Yeah. So here all we're trying to do is identify that Nash equilibrium and whether or not a prisoner's dilemma exists. We had that Nash equilibrium as person one or worker one chooses to work hard. Person two chooses to shirk. Okay. So everybody able to get into that quiz okay? No Wi-Fi issues? Did anyone have a Wi-Fi issue? If I get an email after class, I'm going to say nobody raised their hand. Okay. So it's got, what, 3 more minutes? So get that submitted. We're only going to look at the first 2 questions today. All right? So I'll get these points adjusted when I get back to my office later today, but I'm basically just going to grade you out of those first 2 questions. You'll have the third one you can kind of go back to review. But in terms of like the in-class quiz, we're just going to use these 2 questions here today, and I'll scale the points. Okay? Any questions before we keep moving here? Okay? All right. So if we go back to the slides here, we think about duopoly cooperation. I'm going to do a little bit of review today. Okay? So before we talk about the next topic, we're going to go back and review some of the things we talked about with monopolies. Okay? So if I have a monopolist, and this might answer some questions that people are having on that last quiz, right? Or thinking about questions I could ask you. Let's say I left out these 2 columns here of total and marginal revenue. If I give you different combinations of price and quantity, what is that really representing? The combinations of price and the quantity demanded would be my, yikes. All right, if I think about, I have a marker that works. If I'm looking at different combinations of price and quantity demanded, that would give me my demand curve, right? Now, what should be true? The slope of my demand curve would be what? The change in price over the change in quantity. Okay? We said for a monopolist, their marginal revenue curve will start at the same point as the demand curve, but it's going to be what? Twice as steep. So when I think about when I'm putting these both on the same graph, what's on the y-axis is not technically price, it's dollars. But we can depict prices in dollars and marginal revenue in dollars. So when I'm calculating the slope of my marginal revenue, right, I can kind of think about it here. It's going to be that change in the dollar amount of revenue, right? So it's going to be kind of the change in my dollars of revenue here over a change in quantity, it should be twice as steep. So I think once we go to this table, the slope of the demand curve was like negative 0.5. So the slope of our marginal revenue curve should be negative twice as steep. 1/2 becomes 1, right? Now, what we're then going to do is think about, okay, I've got this marginal cost curve, right? It's increasing marginal costs. Where will the single price monopolist choose to maximize profits? Where marginal revenue is equal to marginal costs, right? So this is going to be the quantity that that single price monopolist chooses. They then do what to set the price? They go up to the demand curve. We can then calculate profits using what equation? Quantity times the difference between price and average total cost, right? So I would have, some average total cost curve in here, right? Now, if I'm thinking about where would the price discriminating monopolist choose to set this price, well, what happens for them? They no longer face a twice as steep marginal revenue curve. Their marginal revenue becomes the demand curve, if I can price discriminate, which I drew this a little bit off. Technically, in the long run, my average total cost curve should be here. They end up where marginal revenue is equal to marginal cost. So that quantity of a price discriminating monopolist is the same as the perfectly competitive market, right? So the single price monopolist chooses a lower quantity, sets kind of a higher price than the perfectly competitive point. But if I'm price discriminating, I'm charging every consumer a different price. This is kind of just a review of what we talked about last week. Okay? So if I'm looking at this in table form, how would I come up with my marginal revenue? If I only gave you demand, how would I calculate total revenue? Price times quantity. So what did I do here in Excel? So this is where I'm not going to expect you to use Excel, but I know that you will be in other courses if you stay in Kelly, right? Or already are using them. So I can actually, you have an example here if you want to play around with it after class. I'm not going to expect you to rebuild this. I'm just going to expect you to know the concepts behind how we would kind of go and calculate this. How would I find total revenue? I simply take that price, multiply it by quantity. Now I'm using cell references here. For the sake of this class, all you would be doing is entering this into your calculator, right? 76 times 8. I then can do that for every single point. Just take price times quantity. I now have my total revenue column, okay? Now, how do I calculate marginal revenue? That's my change in total revenue divided by a change in quantity. So if I take the change in total revenue divided by a change in quantity, that should give me my marginal revenue. Now notice, every time my quantity goes up by 8, how much was the demand curve going down by? 80 to 76, 76 to 72, it's going down by. So my slope was negative 1/2. However, every time quantity goes up by 8, what's happening to my marginal revenue? It's going down by not 4, but 8. So the slope of marginal revenue would be negative 1, twice as steep. The reason why it's twice as steep, we can prove this to ourselves with numbers, just calculating total revenue and then marginal revenue. Okay? Now, from there, if I gave you the total costs, how would you find the average total cost column? You would simply take your total costs and divide it by quantity. So if I gave you total costs and I asked you what is the profit maximizing quantity for this monopolist, well, I know the marginal revenue. What else would I need? I need my marginal costs. And then to find profits, I need the difference between price and average total. So using those total costs, I can find average total by simply taking total cost, dividing it by quantity, right? That's how I came up with this column. And then marginal costs, all I'm doing is looking at what is the change in my total cost, dividing it by the change in quantity. So if I'm looking at these different units I can produce, if I'm a single price monopolist, I want to choose the quantity where what is equal to what? Profits are maximized where marginal revenue is equal to marginal cost. So for these first 8 units, Is my marginal revenue above my marginal costs? Yes. What about here? Yes. What about here? Yes. So what I did over here is I used an if statement. So if you're interested in Excel, we can start to do these things where, like, if this is true, put this value into the cell. So if marginal revenue is greater than marginal cost, 1, yes, I want to produce those units. If it's not, then 0, I don't want to. So notice if I keep going through here, marginal revenue is greater than marginal costs all the way up to this point. My marginal revenue is just barely above marginal cost. So I want to produce that unit. Notice if I went from 56 to 64, what happens to the marginal revenue now? It is below my marginal cost. So would I want to produce those units? No. So the single price monopolist will stop at that quantity of 56. Now, what price should they set? At that quantity, I go up to the demand curve. All the demand curve is this different combination of prices and quantity. So the price the single price monopolist would set would be 52, right? So once you identify that profit maximizing quantity, the price associated with that, or the point you'd be at on the demand curve, that is the price you would set. Now, I have these profit equations. I can do this 2 ways, just to prove to you at the same values. I could just simply take total revenue and minus my total costs, right? Or what's the other form of that equation we had? I can take the quantity I'm selling and multiply that by the difference between price and average total cost. Notice, either way, I get the exact same profit values. Okay? Now, if I've identified this correctly, this quantity of, 56, what should be true about profits? They are maximized. Where is the highest value of profits? 1792. Or, if you're interested, there are functions in Excel where I can identify the maximum, and sure enough, I can see the point where profits are maximized is right at that quantity where the last unit I produced, marginal revenue, is greater than or equal to marginal cost, and that's where profits will be at their highest value. Okay? So that's how I can use a table. I could construct all of these columns. All I would really have to give you is price, quantity, and the total cost column. And you could reproduce all this. Now, I won't give you one this large, like on a quiz or exam, but I might give you one with like 4 or 5 quantities, right? And expect you could come up with total revenue, and marginal costs. Okay. Any other questions before we keep moving here? Okay. Now, why did I bold this one here? So if I have a single price monopolist, we do make decisions off a twice as steep marginal revenue curve. But what other type of monopolist did we talk about? One who could perfectly price discriminate. What does their marginal revenue curve become? The demand curve. So there, I'd be looking for where what? That demand curve is equal to my marginal costs. Well, what is the demand curve in this table? It's just the price and quantity count. So I'm looking for where does the price on that demand curve hit my marginal cost, or where is it greater than or equal to? So for the first 8 units, is that price or the price discriminating monopolist marginal revenue above marginal cost? Yes. 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 All the way down. Now, whoops, at the 64th unit, is that price or my marginal revenue of 48 greater than my marginal cost? Yes. Also for the 72nd unit, the price of 44 is greater than marginal cost of 40. So notice, these were units before that the single price monopolist didn't choose to produce. But the price discriminating monopolist would choose to produce them. So we said with a price discriminating monopolist, the quantity we see in the market will always be higher. Sure enough, the 72nd unit is the last one where price is above my marginal cost. You know, if we look at the 80th, now marginal cost is greater. So the price discriminating monopolist would stop at 72, and kind of the last price they charge would be 44. But remember, they're charging a different price for every single quantity, right? So when you're looking at the profit columns here, this wouldn't apply to our price discriminating monopolist. those are only if we were setting a single price. For the price discriminating monopolist, what we would have to do is go through every quantity and find the difference between what? The marginal cost and the demand curve. All of total surplus essentially became those monopoly profits. Okay? So this just kind of goes to highlight the price discriminating monopolist will choose a higher quantity than the single price. Now, if I'm thinking about what price, if this was a perfectly competitive market, what price would be the break-even price? So if we had a perfectly competitive market, and I'm thinking about, here's my demand curve, right? Here's my marginal costs, right? And let's say I had my average total cost, right? We have these kind of like short-run hypothetical ideas that if price is ever above the minimum point of my average total cost, profits would be, well, price is above average total, so profits were positive. If price was ever below my average minimum point of average total cost, the optimal quantity, price was below average total cost, so profits were negative. The break-even price, it would be that minimum point of my average total cost curve. So if I've calculated, there we go. Now I can't see this on my screen. There we go. If I was looking at where would the break-even price be, it's the lowest possible value of my average total cost. So I can eyeball that, or I can use the minimum function in Excel to tell me what's the lowest possible value of average total cost. Looks like it's here at 18.2. So the perfectly competitive market, I know that in the long run, profits will be equal to, this should be an automatic response, 0, right? Firm entry and exit pushes the price until profits are 0. So there, that price of 18.2 would result in 0 profits for this firm, okay? Now, it looks kind of weird because you're like, well, wait, the quantity actually was lower for the perfectly competitive market? Well, if it's perfectly competitive, do we have one firm? No, we would actually have multiple firms, which was what was driving that competition. So the quantity that each firm produces will be lower, but the total quantity in the market would be higher, right? But we can identify that break-even price by simply the lowest possible value of our average total cost curve, right? Any questions on that idea before we keep moving here? So I'm just rehashing some things we talked about with these markets because we're going to reuse these, right? So we're now going to think about, what if I have these duopoly models, okay? So mono means 1, duo means 2, right? So a duopoly is where I have 2 firms. Let's assume that this was a perfectly competitive market. If I have 2 firms, the fact that there is perfect competition, we're selling the same homogeneous product, we could have firm entry and exit. If I charge a lower price, everybody's going to want to buy from me. So, excuse me, what happens is we basically have this Nash equilibrium where each firm, there's an incentive for them to charge a slightly lower price, which pushes us to this perfectly competitive long-run equilibrium where profits are equal to 0. So if I'm thinking about here, where would profits be equal to 0? It's where my supply would be equal to my demand curve. So if the marginal cost is constant, just to keep it easy in this example, where would my marginal cost hit my demand curve? Or where would the price be equal to 50? Down here at a quantity of 1,100, okay? So if we think about what we're doing here, I'm keeping marginal cost constant, which we can do in a lot of these models just to simplify the visual that you're drawing. So if I've got marginal cost, and we said these 2 firms, right, if they both face the same marginal cost, essentially that is our supply curve. So where supply hits demand, that's going to be our perfectly competitive quantity. Where was that at? 1,100. And I think the price was, well, the price would be exactly equal to our marginal cost of 50, right? So where does marginal cost of 50 hit our demand curve? Or where is the price equal to that marginal cost of 50? Down here at a quantity of 11,000 and a price of 50. This would be the perfectly competitive outcome, okay? Now, if this is the entire market, how much is each firm producing? Well, if there's two firms, each firm is producing 5,500 units, or half of the total quantity in the market. Okay. So we're going to start to have this decision. Firms, if they're trying to cooperate, if they break the agreement and we get pushed to this perfectly competitive outcome, we know that the quantity will be 11,000. The price will be 50. What would profits be? If we get driven to the perfectly competitive point, profits of each firm will be 0. Now, if we could work together, what would the monopolist outcome be? Well, they now make a decision. If they're working together as though they are one firm, right? They want to set the quantity equal to the monopoly quantity, which is where that marginal cost is equal to a twice as steep marginal revenue curve. So I could come up with marginal revenue by doing what? Similar to the Excel example. How did I find my revenue column? Simply price times quantity. How did I find marginal revenue? Change in total revenue divided by a change in quantity. We're just dealing with larger numbers here. So where does that constant marginal cost of 50 hit a monopolist's twice as steep marginal revenue curve? We're looking for what that quantity is. I think on the table that was, where is it at? I think it's 6,000. I'll show you where this is at in the table. And then I would do what? To set the price, go up to whatever price I'm at on that demand curve, which I think we'll end up seeing as 100. So why was I coming up with those values? Where would that constant marginal cost of 50 be equal to marginal revenue? Well, where is marginal revenue 50 at a quantity of 6,000? So if they work together as a monopolist, quantity goes from 11,000 all the way down to 6,000. What price or what point are we at on the demand curve associated with 6,000 units? 100. So the price before was 50. The price is now 100. So if they act like a monopolist together, they would lower quantity and set a higher price. Okay? So they have this decision to make, right? We can work together, choose to put, the quantity in the market at 6,000, which would result in a price of 100. Now, how much would each firm produce here? If the total quantity in the market is 6,000, we have two firms. Each firm would produce 3,000 units. So it basically goes back to that like T-Mobile Verizon example. I'm making a choice between, do I work with this other firm as a monopolist, or do I break the agreement? Right? Because if we both break the agreement, we get to the perfect competitive point and profits are 0. But if I break the agreement and the other person doesn't, thinking that we're going to be able to act like a monopolist, well, then my profits could go up and their profits would go down. Right? So we'll start to think about this in a more game theoretical context now. Right? We have these duopoly models. Do firms cooperate? Right? So it basically goes back to, thinking about that model or that example that we looked at earlier, right? We said there's always going to be this incentive to be the one that breaks the agreement. So what do we see these markets end up at? That perfectly competitive long-run equilibrium, right? Not that monopoly equilibrium where they agreed to, okay? I'll skip ahead here for a second. So we'll kind of talk more about this next class. But just to kind of think of it in the broader context, where are we at? Okay, perfect. What is something, if I'm thinking about these payoffs, right? What could I do if I think that I'm working with another firm and we agree to work together as a monopolist? If I know there's an incentive for them to break the agreement, what could I impose on them that would change the payoffs? I need to somehow increase their costs of breaking the agreement, right? So what might I threaten to do? If you break the agreement this one time, I will never work with you again, which would eliminate any future profits of working with me or create huge costs to breaking the agreement, right? Or, I don't know, you could paint this in a weird one. I don't know, maybe I threaten that if you break the agreement, I'm going to report you to the FCC or whoever it is that you were doing some illegal activity that I know about that they don't. right? Or I essentially am trying to impose additional costs on them to change their payoffs so that I know they're not going to break that agreement, right? Now, can we do this in practice? Most cases, not in most markets, right? Good news for consumers is in most markets, there's always going to be this incentive that pushes firms towards higher quantities, lower prices, or towards that perfectly competitive outcome. So we'll kind of think about these duopoly models. How do we construct them as a normal form game next class? We'll then add in some sequential decision-making stuff where I make a decision, then you do. See how that changes our equilibrium of these games. I want to do a little review of Monopoly, so I'm glad we got that in. Other than that, if you have any questions after class, feel free to ask them. We get out here a little bit early today. Try to stay dry, and I will see you guys on Thursday.